Hello friends, now we will see one university question on matrix displacement method. This university question is for Anna University for the year May 2016. It is a two-span continuous beam. A is fixed support, B is simply supported, C is again a fixed support. Span AB is loaded with 10 kilonewton per meter uniformly distributed load. Span BC is loaded with one point load 20 kilonewton at a distance of 1 meter from point B. The span is 6 meter for BC and 5 meter for AB. Now, we will first calculate the degree of freedom. There is one displacement in the form of rotation, that is theta B at support B. Theta A is 0 because it is fixed support. Theta C is 0 because it is fixed support. Theta B exists. That is the only displacement. Therefore, the degree of freedom or kinematic redundancy is equal to 1. Now, we will first calculate the fixed end moments for both the spans. The approach is the final moment is calculated by superimposing the effect of the bending moment caused by the rotation theta B on the fixed end moment. First, we will assume the support as fixed at all the three places, calculate the fixed end moment, then calculate the impact of the moment caused by the rotation theta B, then superimpose. This is the approach followed. Now, for the span AB, it is WL square by 12. At A, anti-clockwise minus. At B, it is clockwise. Therefore, it is plus. Then for span BC, the fixed end moment formula is WAB square by L square. You can see here at B, it is anti-clockwise. Therefore, WA is 1, B is 5, 6 is L. WAB square by L square, it is minus. Similarly, for FCB, it is WBA square by L square. This is positive because it is clockwise. Now, what is the net fixed end moment at B? We have two fixed end moment at B. One is FBA, one is FBC. Algebraic sum of these two are 6.94 kilonewton meter. This is the moment. Now, if you apply unit rotation at B, and what is the total moment at B? If you apply unit rotation at B, that is displacement number 1, what is the total moment at 1? That is point B. K11 is equal to 4EI by 5. It is 4EI by L is the formula because it is the near side. You are applying the rotation at B and you are calculating the moment at B. It is the near side. So 4EI by L on left hand side. Similarly, 4EI by L on right hand side. Sum of these two is equal to 1.467 EI. Now, this is the moment caused by unit rotation. The total moment caused by theta B is equal to this moment caused by unit rotation into the rotation. That is K into delta is equal to, that should be equal to the net fixed moment, that is minus F. This is the equation. Force into displacement, stiffness into displacement is equal to the total force. This is stiffness, this is displacement, this is the force. Now, stiffness consists of only one element. Degree of freedom is 1, K11 into delta 1, that is theta B is equal to minus F1. You can see here this much. And now from this equation, we get EI to theta B is equal to minus 4.73. Now we have the relationship between the end moment in terms of fixed end moment and also the rotation at the end. Here, rotation at A is 0, rotation at B is theta B, which we have already calculated EA into theta B. Now MAB is equal to the fixed end moment plus the impact of the moment due to rotation theta b. This is the farther end, therefore it is theta b. So we are getting the value of MAB. Now similarly MBA is the sum of the fixed moment plus the moment caused by the rotation theta b. This is the near side effect. Theta b is the rotation and you are measuring MBA. So it should be 2 times theta b, 2 by L into 2 times theta b. Finally, you are getting this is the moment for MBA. MBC is equal to MBA but opposite in sign, because ultimately sigma m should be 0 at B. MBA and MBC should balance. Therefore, you can straight away write MBC is equal to minus 17.05. Otherwise, you can also use the relationship between fixed and moment plus the moment caused by the rotation theta B. Then also you will get the same answer. Now you have MCB. MCB is the fixed moment plus the moment caused by theta B. As far as C is concerned, theta B is far side rotation. Therefore, 1 times theta B. This is fixed moment and this is the moment due to the rotation. This is the final moment. Now, what is the bending moment at the midspan of AB? Bending midspan of AB is point D. At point D, the simply supported bending moment is WL square by 8. Then you have two fixed end moments. This is one fixed end moment, 22.72. This is another fixed end moment, 17.05. Average of these two will be the fixed end moment at D. That is average of these two. And the final moment, net moment, is the difference between the two. So 11.36 kilonewton meter is sagging moment. Similarly, ME we can calculate. This is WAB by L, 20 kilonewton point load, AB by L minus the net moment is to the fixed moment is varying from 1.2 to 17.05. Therefore, the fixed moment at E should be 1.2 plus the difference in between these two ordinates to be taken in proportion. This is the difference in proportion we have to take. So divided by 6 by 5. And this is the hogging moment and this is the sagging moment and this is the hogging moment. The sum of these two values is 2.26 kilonewton meter sagging moment. And now we can draw the free body diagram also. For member AB, you draw the given loading diagram, that is 10 kilonewton meter. You have the fixed end moment calculated as per the equations at left and right as 22.72 kilonewton meter and 17.05 kilometer. Now, if you take moment about this point A, you will get this unknown reaction B. This unknown reaction B will be calculated based on this uniformly distributed load as well as this moment 17.05 as well as 22.72 kilometers. By taking moment about A, using the relationship sigma MA is equal to 0, you will get RB, RBA. That is in the span AB, this is the reaction. Similarly, in the span AB, the total load minus this RAB, RBA will give you the value of reaction at A. Similarly, for the span BC, you have this loading diagram 20 kilonewton and you have this fixed moment 17.05 at B and 1.2 kilonewton meter fixed moment at C. By taking moment about B, using the relationship MB is equal to 0, sigma M is equal to 0, you consider the moment due to 1.2, you consider the moment due to 17.05, you consider the moment due to this 20 kilonewton meter. Considering all these things, the only unknown RC can be calculated in this span BC. The total load is 20 kilonewton minus this value of RC will give you the total value of reaction B at the span BC, 19.3. So this is the total reaction due to movement and this load for the span BC at B. Now the final shear force diagram. This reaction you can draw. This is left upward negative and this is right upward positive at C. Right upward. You take a section here, it is on the right hand side, it is acting upward, put it positive. You take a section adjacent to A, it is upward, but on the left hand side, it is negative. And from this, it is varying to 23.87. There is one uniformly distributed load, so draw a straight line. And then here, there is a sudden drop to the tune of 17.05 Newton. Sorry, there is a sudden drop of 23.87 and then you are getting 19.3 as the total value. This total load minus 26.13 will be equal to 23.87 and then this total load minus this minus 23.87 will be 19.3 and then between B and this loading point there is no load. There is, therefore you make it horizontal. If you calculate the shear force at this point, it will be 23.87 just before B. But after B, if you calculate, the reaction will be 19.3 kilometers. This is left upward and this is right upward and this is left upward. So it is positive and this is negative. And then you have this 0.7 here. Now, the explanations for various steps, such as the relationship between the fixed end moment and the actual moment, the relationship between the moment and the rotations can be found out in the form of explanations given in this RGM website, rgnsite.wordpress.com. Including this page, you can have this as a free download. This website, https://rgnsite.wordpress.com, contains nearly 500 university questions and answers on various topics such as RCC design, steel design, strength of materials, matrix methods, etc. And all of them are available for free download. The download is free. And explanations are available in the form of one word questions and answers. So please visit this site, https://rgnsite.wordpress.com, where you can download all the university questions and answers, including this page. Thank you.